So today is the final day of February. Kiss your short month goodbye.
Yay! Bye-bye!
So we talked yesterday about quote unquote, because we're not actually slicing, but we can call it slices of prisms. So what we're actually talking about making here is these things that when we use the fancy name, what do we call these slices? What's the fancy name for slices of 3D shapes? Oh, what's up, Trophy? Guess that's a bad place for that. Please highlight cross-section. What we're talking about here is cross-sections of two-dimensional shapes. So the problem with using the word slice is it makes you feel like you're going to cut and get a still 3D object. That's not what we're talking about. What we're talking about here is when I shoot a laser through, or when I look straight through a shape, what does that look like? So, let's say we're at a restaurant, and they're serving meatloaf. I actually had not meatloaf last night. My wife is vegetarian, so we made a meatloaf that was not meatloaf. But let's say their meatloaf comes in these interesting pyramidal shapes. And you have ordered it. Now, I would advise you, gentlemen, which is funny that you've sectioned off this classroom. If you go on a date, don't get meatloaf.
Why?
Just saying. Meatloaf is great, but it's just not very classy. So, let's say you're on a date, though, and you want to split this meatloaf. How romantic. And you can have a Lady in the Tramp moments with some slurpy meatloaf. So, hey, bring it back. Bring it back. I can only make jokes if we can recover. So, you ask the waiter to cut it in half. And the waiter cuts your meatloaf like this, straight across the middle. Now, hold on. So hang on to your comments. Ponder this for a second. Could your pyramid of meatloaf, when cut horizontally, could the top and bottom halves end up with equal amounts of meatloaf, like with equal volumes in them? Could it?
Maybe.
Why does it depend, Flynn?
Because it's like, it's where you cut it. Maybe if you cut it right at the tip, that won't be enough. If you cut it too low, then the top part will be too much.
Love it. You understand what Flynn is saying?
I think of Fruit Ninja.
That's not how.
I love it. Think of Fruit Ninja.
Oh,
Except I don't play Fruit Ninja, so I'm not totally certain. But where you make the slice depends on how big each portion is. Flynn said if I make the slice at the top, like near the top of it, obviously the bottom half will have more meatloaf. If I make the slice way down low, the top half, or top portion, shouldn't use the word half, top portion will have more meatloaf there. So there's some perfect spot that could. So this could happen. So let's over to the side here. Yes, it could. It could be even, but nope, oh, there we go. What would be a better way to slice it, an easier way to cut it to get even halves? Zader? So, a vertical slice, let's use our math words, a vertical slice would be better. Sorry that my E's don't always loop.
Wait, what about cross-section?
So that changes what our cross-section would be.
Oh.
If I sliced horizontally, perfectly flat, horizontally, gravity works, through this shape, I knew it was going to happen. What would the cross-section shape be? I slice horizontally?
Square.
Square, right? So like it shows down here, if the base is a square, my horizontal will be a square. If the base is a rectangle, like they show here, then my cross sections are rectangles. What if I slice through vertically though? What would that cross section be? Abby? A triangle. So depending on how we slice, depends on what cross section we would see. So let's continue talking about what our cross sections actually mean. Sorry, that should have captured my board slightly off today. So a horizontal slice will always keep the same shape as the base. However, they will always
Good morning, Olivia Berry. Please come to the office. Olivia Berry to the office, please. Thank you.
have a different size. So horizontal, I'd love you somewhere so that you have this in your memory to write same shape, different size. Bless you. So the closer to the base I am, the bigger it is. Closer to the top I am, closer I am to disappearing into a point. And this is a question you will see again. So again, I'm trying to help you. What if my base here was 8 and 10, and I say that my green slice is exactly halfway up the pyramid? Could I figure out the lengths or the edges of that rectangle? Hayden? So these could be 4 and 5 if it was exactly half. So if you know how far down the shape it is, you multiply that with your base dimensions to find your new dimensions. So let's say this was 1/4 of the way down the shape. Well, so 1/4, here this would turn into 2, and this would turn into 2.5. They're always going to be proportional. So also off to the side, they're proportional. 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 Hey, that was loud. Oh no, that means we're not recording audio, or might be recording audio. Who knows? Actually, I think it was when you guys came in. It probably just defaulted to a different mic, so we'll see how this sounds. If this ends, I think it's using this mic now is the issue. If it ends up sounding like crap, I'll just refilm in the afternoon. But yeah, that definitely means that I screwed something up. I forgot to plug it back in after showing that video. So, vertical slices need more detail. I need to know if, and you need to highlight this because this will change a lot of things, is it through the vertex? If it's not, I get weird shapes, like trapezoids, awkward rectangles, mainly trapezoids. Cannot get circles unless I have a cone. But if it's through the vertex, whether I go through the vertex like this, through the vertex like this, or through the vertex diagonally, I'm always going to create something with a tip, 2 sides, and a base. So what is that? A triangle. No matter how I cut it, I'd get a triangle. So these triangles, though, will have different sizes because this blue triangle, if this is the width of the shape, that blue triangle will have the width. If this is the length, that purple triangle has the length, but they would both share what? What would they both share the same? The height. So both of them will have a height that is the same. Because if it's through the vertex down to the bottom, they'll both have a height that is the same. Questions?
What is that
when I take a snapshot, it turns the wrong way apparently to turn it down. So, draw and label what you know. If we don't know the dimensions, you don't have to label it, but we're going to label what we do know about it. So here on my first one, I have a vertical cross-section going through the left and right, because obviously it doesn't come out of the front face. Joe, what dimension do you think that cross-section that we're going to get is going to share with the original pyramid? What do you think we're going to keep? So remember yesterday, one of the questions we could ask ourselves is, what do we cut through? If I cut through it, it's gone. I can't use it. Do you need some help getting there? So when I look at my cut through, I went left to right. So I cut through this edge. That edge was my 6. Right? So we cut through the 6. When I look at the cross-section that gets created, it's going to be right there. What dimension could it have the same as the original pyramid? So will it keep the 3 or will it keep the 6? That's our question. Yeah, because this length here will be the same as this length here. So this would have to be 3 inches. We do not know the height. That's the only thing we know about it. Kylie, what about our second one there? What type of shape am I going to get? Then we'll determine what we know about it. What type of shape is at my base? So what type of shape am I going to get? A rectangle, not a square. So we get a rectangle. That's probably slightly off. Probably drawing a bit too long. Now, do I know anything about those dimensions? Now, I'll tell you, we don't know what they are, but we do know something about them. Can you tell me anything about them, Kylie? You can't. It's okay. So, my short edge, what do I know about my short edge? It's going to be, so less than 3, right? And my long edge has to be less than 6. But I agree, it's some fraction of that. So if we said that that was a third of the way down, so what if we're now told that this is a third down the pyramid? So if we now know that, well then I could say, okay, what's a third of 3? What's a third of 2? Third of 6? I know, way to say the answer. So if you know the fraction, then you can figure out the lengths. But if you don't know the fraction, you just know it's smaller. And our third one here, Mr. Surface. What dimension do we keep from that one? We keep the 6 inches, so that will become a triangle with a wider base. The 6 inches. Any questions, comments, concerns from any of these? Abby.
When you said in the beginning it would be destroyed if you cut through it, why would it be destroyed?
So imagine that I'm trying to figure out the slice through the left and right sides of my pyramid. So I'm going to cut this in half and then pull away the front and only look at where my slice is. So if this was 4 inches, and I slice down like this and I pull the front off, that 4 inches has been cut. It no longer matters, but the distance along the front, when I yank this off, will be the distance across the bottom. So that distance across the bottom will be the same as what this distance was, but this distance doesn't matter anymore because it got cut.
So the original measurements would be destroyed?
Well, one of them gets destroyed. Whatever one gets cut through, like here I cut through the 3. So now this section in my pyramid this 3 doesn't exist. This 6 still does, because that's how long the base is. But this 3 doesn't matter anymore because my shape is no longer 3 dimensions.
This 3's been like cut off.
Yeah, the third dimension disappears. There's no third dimension.
I get it now.
So you're choosing 2 dimensions to keep. You're getting rid of a third dimension. Thank you for making me clarify that. Move to the back, please. Try this on your own. And if you're really on it today, try the got it. That's a challenge problem right there. Most people can't figure out how to do that. And what does it mean to be an isosceles trapezoid? Yeah, that was rhetorical, not answer out loud yet. You're okay. I did not clarify. Did you get a permission form this morning? Okay, so to have it as a potential plan, if you find out that you can't, all you need to fill out is this section, but not participant 2 or participant 3 because there's only one of you, and then this section, just because there's just you. And this is where they formally sign that they're giving you permission to do this. So this is just to get your info, like if you need emergency information, whatever, in the back part. So if you end up wanting to go. Yeah. Oh, sweet. Thank you. I need your name and your mom's printed name. Even if you just do that, I don't care. But your mom signed it, so I just need your guys' names written out there. I can't fill that out legally. So, Julia, if we look at the triangle formed when I make this vertical slice, so we can kind of see that it's going to make a triangle. So I'm going to kind of draw mine at a slight angle, sort of like if you had pulled it out. But what dimension did we keep there? You got it. So that 6 inches is pointing to correspond with the height. So you're absolutely right. Our height is 6 inches. And then what else do we know?
That the bottom is 4.
Yeah, we cut through this 4, but this length here will be the same as this length here. So this is also 4. Ooh, be careful. We don't know what these lengths are. Now, if this is a regular pyramid means the shape at the bottom is regular, the vertex is in the middle. If it's a regular pyramid, then we would know that these would be the same. If it's a regular pyramid. Yeah, so imagine if I took this pyramid and pulled the vertex off to the side. It could still be a pyramid because I have a base shape and I go to a point, but it would not be a regular because all the faces would not be the same. In a regular pyramid, all the faces around the lateral have to be the same. So like another regular pyramid is a regular pentagonal. So now I have 5 faces that are all triangles. A regular hexagon on the bottom, 6 faces around the side that are all the same. I do not have any models of non-regular pyramids.
Put any shape at the bottom and meet them at the top and get a triangle.
Yep. Well, if you any shape at the bottom to one point, that's called our vertex, where you go from an edge to a point, making triangles, then yeah, you get a pyramid. So it might be an interesting kind of pyramid, but it's a pyramid. So all that pyramid really defines is you start with a shape and you go to a vertex, a single vertex point. So, an isosceles trapezoid. So, Izzy, was it you that was trying to inform us what isosceles is? So, what is isosceles? 2 lines what? That actually is part of. So you're thinking what parallel tells us, not necessarily what isosceles tells us. Now, a trapezoid will have a set of parallel lines. So I'm not saying that you're wrong, but that's not what isosceles means. Glenn? Ooh, yeah, so two edges. Be careful, you said points there. So this tells us two congruent, which means same size. Two congruent, please use that word so you get familiar with the vocabulary. Two congruent edges. Trapezoid tells me, what does a trapezoid have to have? So it's a quadrilateral. Yeah, we need a little bit more than that. We have parallel.
You only have to have one set of parallel lines.
Yeah, so it's a quadrilateral with parallel. That's our symbol for parallel. Two lines going the same direction. Parallel bases of different size. You don't have to be able to describe it, because you can come show it. How could I take my square pyramid, Flynn, and cut it to make a trapezoid? Sure. Now I will tell you, the smartboard's kind of off. So set it there, figure out where you are, then start drawing, because then your brain can kind of adapt. So I mean, it's slightly high up. It's very awkward.
Well, I'm just gonna show it. So
You can show it on the physical pyramid if you want. This might be easier to talk about.
So I'm just gonna cover this top. So where my fingers are, you just cut off like that top and then just make a trapezoid shape.
So I'll help you out with drawing it up here.
Yeah.
So what Flynn's trying to show is I choose a side to have an edge that I cut a little bit higher, and then I could come down the front side, across that back one, and down that back one. But what Flynn's trying to show is a diagonal slice anywhere. Doesn't matter where you come in. If it's a diagonal slice, I can go through down to the bottom. I could go through over to the other side. So I can do another one of these that started back here that actually comes way down to the bottom.
Good morning, Mia Ciprio. Please
Yeah.
come to the office. Mia Ciprio to the office, please.
So I like what Flynn's saying. If I just take this point off, but you got to make sure it's diagonal.
Yeah.
Okay, so if I go straight across, I end up with a rectangle. Perfect. Anybody confused? No, not in with Flynn. Is he? So if I cut it horizontally, I'm going to go straight across. I get, like, if my base is a square, I'd get a square. If my base is a rectangle, I'd get a rectangle. What we've done up here, like if I pulled my red shape out of this and turned it flat, is this edge created me a short edge. These front and back faces created the legs of my trapezoid. And then this edge across the bottom is this edge across the bottom. So this will be the same length as this, and that will be parallel with that. It's a weird idea to comprehend. Sorry, I know it's gross. I'm still getting over being sick. Let's try just following directions for our cut. So move on to this example. We might come back to this. I might physically make a pyramid at home and cut it on my table saw to try to show you guys what we're trying to do. And I'll just bring it in to show like where the cut was, what cross section gets made. Underline or highlight the important info here. Plane's got to be vertical. Intersects the front face. and the vertex. That's important that it's got the vertex. So try to draw that on your own. Now, some people have issues with this. The front face is the closest face to you. And so this, the long side, that's our front face. That would be our right face. Back here would be our back face, and then our left face. It's not flat. On the paper it's flat, but the shape itself, what we're trying to visualize and represent, is not flat. Does anyone have class with Ethan Dale, second block? Will you check if he picked up a permission form? He texted me about that last night, and if not, he just needs to come get a waiver from me. So when I slice through my front and my vertex, that really tells me the first line that I could draw. You want to come do it or describe it, or if you want to come up, you're more than welcome to. There you go, sir.
Start right here, down the center.
Yeah, it's hard to show.
Start here, cut through the center. Let's be vertical, so it's going straight down.
So the slice is vertical. You don't have to be too because this line is technically not straight, but the slice is vertical. I'm going to make a minor tweak here, which actually, let me see this. I'm going to set this down. So his front line's perfect, and his line going across the bottom is good. This back one's a little off. So that front line, I'm going to go ahead and leave. We can use that one. As I go across the bottom, I'm going to just make all of these solid, even though we can't see it. And then I come up the back. So what I end up making is what shape?
A triangle.
A triangle, because any vertical slice through the vertex is going to make a triangle. So any vertical slice through the vertex is going to make a triangle. Xavier?
Next one.
Yeah, so horizontal, halfway up the pyramid.
Okay, so this one.
Yeah, it's slightly off. I'm telling you guys, this smartboard's getting worse and worse. We probably won't be able to do much until summer, just because it's so constantly in use. Do you want some help? The trick is don't lift the pen. That's what you have to be used to. So, I know what you're trying to draw. So Xavier's trying to draw. I'm going to scoot it down a tiny bit so it's a bit easier to see. Across the front, that's about halfway. Then I got to go parallel to my edge. So that's kind of hard. I'm trying not to lift. Then across the back and across that other edge. So I end up with something kind of like this. See what I mean? By if you don't lift the pen, it's a little bit easier. Because I can just kind of keep where I want it to be. So we end up, if this is a rectangular pyramid, what kind of shape does this give me? A rectangle. And what else would we know about it? How will the size compare to the base? Abby? If it's halfway. Now here's the trick. We don't want to use up though. To figure out size, we want to use how far down. So I would actually change that up here to down. That's how you determine the size, is what fraction is it down. Because if you went up, imagine, what if you're 3/4 up? Well, now you're smaller. 4/5 up, 8/9 up. That's why you want to go down. I'd be 1/9 down. I'm 1/9 the size. 3/4 down. I'm 3/4 the size. Questions? So, draw and describe two triangular cross sections, each formed by plane intersecting the vertex, and they're both perpendicular to the base. How can I do two different? Casey, what do you think? Yeah. So it would seem like more of your attention was probably devoted to Abby's hair. We're talking about two cross sections. We want them to be different than each other, but we want them to both go through the vertex and be perpendicular to the base. What's perpendicular mean? Do you remember that, Casey? What kind of relationship does perpendicular tell us? Parallel is never touches, right? They are the same direction forever. Railroad tracks. Perpendicular. How do they cross? They make a 90-degree angle. Our symbol for perpendicular is the upside down T. The upside down T shows two lines that are intersecting in 90-degree angles. So, how do I make two different cross sections? Xavier?
Well, you can have one that's going vertical through the front face and the back face, and then one through the left and right.
So one is going to be through front back. Not through face, but through the front back. My second one can be through, if you want to copy a word directly above, you just make the double tick marks. That means ditto. It's the same as above it. Through the left and right. So that red one comes just like this. So now part of your homework is being able to look at different perspectives. So what we've really been doing here is changing your perspective. Am I cutting through this direction or am I cutting through that direction? What will it look like based on that? So it'd be very hard to digitally have you drawing cross sections. So a lot of your homework is saying, if you view this image from the top, or if you view this image from the right. So it's all about perspective and vantage point, and what do you see from certain perspectives. So come see me if you have any issues with that. We want to explain how to slice a rectangular pyramid through the vertex to get triangles of many different heights. So we have a rectangular pyramid. I know that it's a rectangle at the bottom. So this is square, but a square is a rectangle. I have a pyramid just like this. I want to make different heights of triangles, but they all have to be through the vertex. They have to be different heights. What doesn't this tell me? Think for a second what it's not telling me about my cross section. Okay. Well, it kind of does tell me I need different heights. What do most of my cross sections tell me to begin with? Do they say make a cross section that is blank or blank or blank or Shane? So here, And if it doesn't say anything, maybe it's not. So what if I do a vertical cut? Right? I get a triangle. Just like that. But what if instead of going vertical, I now, instead of cutting like this, cut like this, and cut at an angle? What will happen to the distance between this point compared to the center?
Gravity works.
Gravity totally works. The center of the base compared to as I scoot out from the vertex to those points on the base. How would this distance compare to this distance? Andrew?
Wouldn't the center be smaller if we were going from a cross section?
The distance straight down will be shorter than the distance diagonally. Because a diagonal distance is always longer than just a straight distance. As soon as I go off straight and I go diagonal, that's a further distance. So what if we do a different one of these that goes down the edge and literally cuts the front face off of this? That distance will be longer than the red one. So our trick here is to cut diagonally. That's how we get our different sizes. We want to cut diagonally. The more diagonal it is, the bigger it is. The more straight it is, the shorter it is. Andrew? What's that?
You can also make different base sizes if you just turn the base.
So that's diagonal, diagonal,
Yeah.
right? So if I turn diagonal and lay diagonal, I can make a different length of base. But all they cared about was different heights. So yeah, if we wanted different base sizes, we turn diagonally and then lay diagonally. So diagonal, diagonal. Justin?
The only triangle where you can lay it on the side and it'll stay, or a pyramid, you can lay on the side and it'll still be a pyramid. Or like
So
look the same visually.
there is only one like that. This one is not like that. A regular triangular pyramid, if made perfectly, that this triangle is the same size as this triangle is the same size as this. That one you could lay on any face and it would look the same, but notice this one doesn't. This is not made perfectly. These legs are longer than these legs. So this is not a perfect regular triangular pyramid, but that would be the only situation where that could work. So because this, once I lay it on the bottom, now it's a triangular, like, it's still actually a square base pyramid. It's just laying down. Even though the triangle's on the bottom, it's still a square pyramid. It's just been, like, this is still a square pyramid. It's, yeah. Because remember, in geometry, there's no technical up and down. Like, it's just space.
That's why I changed my word.
Yeah. What's up, Brent? Oh, you filled this out. Thank you very much.